Well, look at that. We're already to problem set number 5. So use the derivative to find where the function is increasing and decreasing on the interval from 0 to 2 pi. So this one's got sine squared minus cosine. I'm going to change it up a little bit and do sine plus cosine. So usually I will take the derivative and then do all of my work by hand, and then I'll check my answer on the calculator. But sometimes I like to switch it up a little bit and graph the function first. So if we graph sine x plus cosine x, and it's in radians, and change the window to go from 0 to 2 pi, and then the y values, sine and cosine both, the biggest they get is 1. So the biggest this would get is 1 plus 1. So I'm going to say go from -2 to +2, and then see, can I see the whole graph? So I'm trying to find out where it's increasing. So increasing from here to here. So there's one place where the derivative equals 0 right here. There's another place where the derivative equals 0 right here. And I don't think the derivative equals 0 there, because I think by symmetry it would have been, so it's possible, but I'm sort of doubtful. I think there's going to be 1, 2 answers that we're looking for. Okay, so first of all, for the derivative, and of course, I have all of my derivatives memorized from this 3x5 card. Here's the derivatives of the trig functions that I inserted into my memory cube. So the derivative of sine is cosine, and the derivative of cosine is negative sine. And then set this equal to 0. And then the next thing that I will do is take this sine and move it to the other side, so that it's going to say sine x equals cosine x. And if you haven't watched the extra video about solving trig equations, which doesn't have calculus in it, it's just a review of trigonometry, you should look at that. It's there on Canvas. So the next thing I need to do is get this to be one trig function. And one way I could do that is divide by cosine, because that way on the right side it's going to eliminate the cosine. And then the other good news is that sine divided by cosine equals tangent. So I just have tangent equals a 1. So then if you use tangent inverse, or perhaps you have the unit circle memorized, but if you don't, you can use a calculator and say, find me second tangent inverse of 1. And then you look at that and you go, hey, wait a second, isn't that pi divided by 4? Pi divided by 4. Oh, that's pi divided by 4. If you didn't know that that's pi divided by 4, here's what you can do on the calculator. So you do the second inverse of tangent inverse of 1, and you get that decimal answer. Now don't type the decimal, but just hit divided by pi, and then go to math and convert that to a fraction. And then it's telling you it's 1/4 of pi. So how many pi's is it? It's 1/4. So it's going to be pi over 4. So x equals pi over 4. Now the tangent function itself has asymptotes at negative pi over 2 and pi over 2. So if you look at the tangent function and then you want to know where that equals 1, that means go across and there's an answer right here, and that's going to be pi over 4. But if you remember from looking at the graph, there was 2 answers. So this one should be pi over 4. Trace and put pi divided by 4. That should be that point. Yes, it worked. But there's going to be another answer. So if you go back to this little graph of the tangent function and you were to draw the tangent function again and you continue this over, there's going to be a second answer over here. Well, as you drew the first, or as I drew the first branch of the tangent function, the distance between negative pi over 2 and positive pi over 2 is pi. So that's the period. So if you want to jump from this answer to this answer, then add pi. So just add a pi to this. And if you have a whole pi plus a quarter of a pi, then this would be 4 over 4 plus 1 over 4 makes 5 pi over 4. So I'm pretty sure that's going to be the first answer, and that's going to be the second answer. And now double check, is this one the 5 pi over 4? So 5 pi divided by 4, yes! So we have the two solutions. Then the directions we're saying, where is the function increasing? So when is it going up? So from 0 until the pi over 4, that's going up. And from the pi over 4, the 5 pi over 4 to the 2 pi, it's also going up. So for increasing, which I like to just abbreviate like that. So for increasing, that would be from 0 to the pi over 4. So that's, this part is going up. Now 0 was not one of the answers. So if I change the window and I just go to the left a little bit more, then you'll see as it was going through when x equals 0, this whole time it's increasing. So at the moment it hit 0, it was increasing. So that means this gets a square bracket. But at pi over 4, that's when it's at the top of the hill. So right there, it's not increasing and not decreasing. Oops, got some ink on there. So this is a round parenthesis. And then also from 5 pi over 4 to 2 pi, it's also increasing. So 5 pi over 4 to 2 pi. And the same reasoning at 5 pi over 4 itself, it's not increasing because that's when it's at the bottom of the hill. And as it goes through 2 pi, it was increasing, so this one gets a square bracket. And then put a union in between, and we're done with that one. And then so this is similar, although when you take the derivative and set it equal to 0, you'll probably have to use the quadratic formula, and that's how come I said use 3 decimals. And then similar on this one, use 3 decimals, so you're probably going to have to do some algebra after you take the second derivative. And I'm going to do one similar to this with the second derivative to see where's the function concave down. There it is. Okay, so for concavity, concave up or concave down, we need the second derivative. So first things first, the first derivative, well, that's an e function, so the derivative is the e function. And then the chain rule says take the derivative of the square root function, and that is going to be 1 over 2 times the square root function. Now you could treat this one as a product when you go to do the second derivative, or you could just say this is e times 1, so I could just rewrite this as the e function on top and the 2 square root of x on the bottom. And now do the derivative of the derivative, aka the second derivative. And this one is a quotient, so I'll be using the quotient rule. And the quotient rule says start on the top and take the derivative. So that's the derivative of this e function, which is this right here. So we'd have the e function over 2 times the square root function. So the quotient rule says start on the top and take that derivative. There you go. Whatever this is, just multiply with it. So then times 2 square root of x. Then the quotient rule says minus. Now whatever's on top, just copy that down, the e function, And then take the derivative of this. So 2 times the square root function and take its derivative. So it's going to be 2 times, and then the derivative of the square root function is 1 over 2 times the square root function. All right, that's the numerator. And then for the denominator, you just square it. So 2 squared will be 4, and then the square root and the square will cancel. So it's 4x on the bottom. And then set this equal to 0 and solve for x. Well, when I set this equal to 0, for one thing, when you have a fraction, so this is one big fraction, the derivative, or excuse me, the second derivative will equal 0 when the top equals 0. If you put the bottom equal to 0, that's where it's undefined. So that's easy enough. That's just x equals 0. So x equals 0 is a possibility from this one equal to 0. And then you can separate it and do the top equals 0 separate. So when I put the top one equal to 0, let's see, I'm tempted to cancel these, but the thing is this and this, they both have the same thing. So I think I'm just going to leave it for now. So it's going to say e square root of x over 2 square root of x times the 2 square root of x. And once I put it equal to 0, then I could take this negative term and move it to the other side. I'm just thinking, is that the best thing to do? Yeah, I think I will. So I'm going to take this and move it to the other side. And it becomes positive. So let's see, the numerator has the e, and then it has 2 times 1, so that's a 2. And the denominator has 2 square root of x. All right, so I was thinking of leaving it like this and factoring it, but I can also take this and move it to the other side, and then I can multiply both sides by 2 square root of x. And the reason for doing that is cancel, 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 cancel. And then also, while I have the red pen out, I could divide both sides by the e square root of x. And the reason for that, cancel, 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 cancel. So all that's left is this and this. So all that's left is 2 square root of x equals 2. And then just divide both sides by 2, and the square root of x is equal to 1. And then square both sides, so x equals 1. So x equals 0 and x equals 1 are the two answers that we get for the second derivative either equaling 0 or being undefined. And then let's see if we can see where it's concave down. So graph the original function. So I don't need this trig anymore. And it is the e function and then second square root of x. And for the window, I do need to see what's happening at 0. So -1 sounds fine. The other number was 1. So maybe if I go from -1 to 2, I can see what's going on. And I don't know what to put for y, so I'm just going to put -10 to 10. And then can we see where the function's concave up or concave down? To me, okay, so this is concave up and this is concave down. Concave up, concave down. When I look at this at 1, I cannot tell the difference because to me this looks sort of like a straight line. So maybe if I eliminate some of this and some of this, so I don't need any negatives on the y and I don't need any negatives on the x. So I don't need any negatives and I don't need any negatives. Does that help? No, not really. And sometimes this happens that you can't really rely on the graph, so it's not obvious like this is concave up and this is concave down. But according to the math, there is something that's going on between 0 and 1. So then what I could do is go to the function, the second derivative right here, pick a number between 0 and 1, like a half, plug that in to the second derivative and see, is it positive or is it negative? So for that, I'm going to need another piece of paper. And so here is the second derivative, and then plug in, let's say, the half. So not into the original function, but into the derivative. Okay, so for one thing, it's one big fraction, so I need a parenthesis. For another, I could go ahead and cancel this and cancel this and cancel this and cancel this to make it a little bit easier to type in the calculator. So we need the e function, and then the square root of a half, or 0.5, and then that is times 2. So I need to get out of the exponent, times 2, and then minus the e function. And this is also the square root of a 0.5, and then move to the right and move to the right. And these have canceled. I just need to divide it by the square root of x, or the square root of, so divide by the square root of 0.5. And then it's divided by 4 times x, so divided by, and I should put that in parentheses, 4 times a 0.5. The number itself doesn't matter, but what matters is that it's a positive. So if the second derivative is positive, that's concave up. So believe it or not, that was concave up in the middle. So my actual question was, when is it concave down? So that means that between 0 and 1, so it's concave up between 0 and 1, and then concave down from 1 to forever. So even though the graph is not obvious, then this part is concave down.